All right, welcome back to part two. Now I'm going to start talking about architecture and how all those biases and stuff actually affect the real intelligent system I'm building. But first of all, let's talk a little bit about the brain. So the brain receives inputs from the senses and makes actions by using the muscle controls. Now the brain material itself is made of a reasonably homogeneous material. For the most part, it's just axons and dendrites and neurons. Using that same material all through the brain, we learn or we're born with all of these different abilities. And it's not as simple as that. Some of these abilities we're neither born with nor learned. Some of them we do a bit of both. Like, for example, the ability to see. There's some sections in our brain which we're born with which help us to see. But also over time we learn to recognize faces and we learn to see trees and flowers and so on. Now, when I talk about the brain, I want to be very, very clear. As an intelligence researcher, I'm not interested in building the human brain. I'm interested in building intelligent systems, and they're different. This top picture and this bottom picture, they're quite different things. The brain is an implementation of an intelligent system, but it's not how all intelligent systems will work. When we're building intelligence, we don't want to copy the brain. We want to take inspiration from the brain and use the ideas that we can find in the brain as much as we can. But we don't want to build another brain for a whole bunch of reasons. The primary one being that there's no good reason why the human brain is going to be the best example of how to build intelligent systems. So, how have artificial intelligence researchers actually approached this problem in the past? There's two sort of ends of the spectrum as far as I see it. One end you've got the neural network community, and they say, look, let's, instead of trying to build intelligent systems directly, let's try and copy the architecture of the brain. Let's try and copy the fundamental building blocks and copy neurons and dendrites and so on, and then see if intelligence emerges out of the rubble. The other side of the spectrum is the roboticists. And they say, look, trying to get our systems to learn on their own all of the complex structures required for vision and mapping and everything else is just too difficult. Let's ourselves program in all of the specific behaviors that we want, and we'll use learning methods to try and get a bit better at these different tasks, but not make the robot have to learn each of these tasks from the ground up on its own. And I think of these somewhat as saying, well, let's make the robot born with all of these abilities versus let's make the system learn all of these abilities. And it's not as simple as that. I mean, the roboticists are trying to get their robots to learn as much as they can. And the neural networks guys are sometimes trying to get their neural networks to come pre-programmed with some of the behaviors that they want. But it's kind of a mucky and fiddly and strange world. Remember in the first set of slides I showed you this, that we can build individually these chess-playing AIs and vacuum-cleaning AIs and sonnet-writing AIs, but I'm interested in a generalizable intelligence. I'm interested in something that can do all of this stuff. So with all of that in mind, how do I actually want to build this stuff? What is my architecture? Well, the way I want to start is with something like this. I want to have a world model. So my intelligent system has inside it a picture as far as it's concerned of how the world actually works, especially its body and its physical inputs and outputs. So you can imagine a whole bunch of inputs flowing into the system, and the point of the world model and of the input model part of the world model is that it should be trying to model how its inputs behave. For a human, this is the equivalent to vision and all of our sensory perceptions. Then we want to be able to model our rewards. And the common terminology for this is a value function when you look at the reward function from the inside of the intelligence. The point of the value function is it'll tell the intelligent system how the world looks when we get rewards or when we're punished. This is really important. I know just from thinking about fire that it will hurt if I put my hand in it. When I think about fire, I'm actually using my world model, and I'm using my world model's knowledge of fire to tell me what the value function is if I, in fact, put my hand in it. On top of that, we want to add an action model. So the point of this is the same as the input model, but for our actions. As we perform actions, how are these going to affect our world? And with all of that put together, we can build a choice function. We can build this choice function by saying, all right, so I know how my world works. I know what makes me happy. I can imagine the different actions I can perform, and I know how that's going to affect my world. Through the process of imagining how the world will change, I can decide which of those different worlds will be the best, according to my value function, which is itself described through experience by my reward function coming in. And I'll use that to make choices. And over time, those choices are going to do the intelligent thing, which is to say, optimize my actions with respect to my reward function. And that's my output. But I'm going to forget all of that. The most important thing right now is that I get my input model working. And this is all I'm going to be focusing on for the next kind of ages. But we said last time that we can't make an intelligent system from just an input. But we also said that you can imagine a kid in a coma who's receiving inputs from the world. And so long as the intelligent system can kind of be understanding the world, you can still think of this thing as vaguely being intelligent, so long as we can get predictions based on that understanding about what's happening in the world. So this is the world, or this is the environment into which I'm going to throw my intelligent system. My intelligent system is going to receive inputs from the world. It's going to just build up the input model inside its world model. Based on this model, it's going to make predictions about how it thinks the world's going to behave in the future. Its reward function is going to be the predictive accuracy of these predictions that it's making. And over time, it should be optimizing its predictions to maximize that. You can think of this like this, that the intelligent system is receiving inputs from the world. It knows how good its predictive accuracy is, and it should be making predictions about the world to optimize its predictive accuracy, which is to say, it should be making predictions about the world as best as it damn well can. Alright, so how does bias come into all of this? Because I talked a fair bit about it. So if you think of this system like this, it all kind of makes a bit of sense. And a very important part of this is that the world model that the system is building should eventually equal the world sitting outside the system. The intelligent system should be building up this world model so that it can predict how the actual world's working, and that's what it's going to use to make choices over the space of its possible actions. Now remember that the world is actually unknown. We don't know what the world looks like. All we have is inputs coming in, and we make predictions going out about how that world behaves. In reality, there's a bunch of different worlds that could be giving us that input, and we have to choose between them when we're building our world model. What does this remind you of? It should remind you of this. There's a bunch of different patterns which could be generating these first three numbers in this sequence, and we don't know which of those patterns is really going on, is really being shown to us here. Now, out of all of these different patterns that we could be seeing, what we really want to do is we want to pick 1, 2, 3, 4. Why do we want to do that? Well, two reasons: simplicity and induction. Simplicity says we want to pick 1, 2, 3, 4 because 1, 2, 3, 4 is the simplest pattern, and induction says 1, 2, 3, 4 is the best because that comes up all the time and it's very, very common. I'm going to rewrite these using slightly different words. By simplicity, I mean I want a small model, and a small model is better than a big model all the time. And by induction, I mean I want to learn patterns. And that's how our biases work. So the point of the biases is that we're building our world model, and our world model should be trying to model or trying to track the real world and what's going on in the real world. My intelligence system is initially going to be specialized for this particular problem of receiving inputs from the world and making predictions using those inputs. Our reward function is the predictive accuracy, so we're optimizing to make the best possible predictions given the input that we're receiving, and the best possible predictions over a long time. And that's the intelligence I want to build. Eventually, I want to put all those other things into my world model and put in that choice function, but for the moment, this is all I'm going to make. And yeah, that's my plan.